This video is over section 2.4, rates of change. And in this video, we're going to go through an example of a problem that's really similar to number 27 in your book. So let's go through this problem. It tells us that after your first math test, you throw your calculus book in the air from ground level and return to the earth 5 seconds later. Find the initial velocity and the maximum height of your book. Okay, so if you watched the previous video over number 14 in your book, to solve that problem, we had to find the derivative of the function they gave us, plug in a point of interest, and answer the question that way. In this problem, though, we're going to solve it using the formulas that they gave us in this section. And if you remember, they gave us a formula for position and for velocity. So let's go through what they gave us, figure out what they're asking for, and then determine which function we're going to use. All right, so it tells us that we threw our calculus book in the air from ground level. So we threw it from ground level. That means our initial position, S0, is 0. And it returns to the earth 5 seconds later. Okay, 5 seconds is our time. Our total time of travel was 5 seconds. And actually, this also tells us another value. Because since it's saying that it returns to the earth after 5 seconds, that means that our position at 5, if we were to plug 5 in for t in this function, our position would also be 0 since it returned to the earth. And it's asking for the initial velocity, which is v0, and the maximum height. So I'll write that as s of t, our maximum height at some time t. Okay, there's a couple of different ways you could approach this problem, but I'm going to solve it using this first function here. Since they're asking for a position, I have to use a position function. And since we're also looking for v0, this function works for that too. Okay. So I have two unknowns that I'm looking for. If I weren't sure which one to start with, I could just think about what they gave me and see what would work. If I tried looking for my maximum height first, I would look at my function and say, I have too many unknowns here. I don't know my v0, and I also don't know the time at which my maximum height is. So I wouldn't be able to solve for my maximum height first. So let's move on to our v0, see if we have enough information to solve for that here. So I'm looking for my v0. I have my s0 is 0. And I also have a t and an s of t that correspond that I could plug into here. I could plug in 5 for t, and since I know my s of 5, I have a value for this side of the function here as well. And that would leave me with just one unknown, my v0, which means I'd be able to solve for this variable. Okay, so let's plug everything in that they gave us. So using this function, I can plug in all my values. My s of t, or my s of 5, is 0, equals my s0 is also 0. Plus v0 t, v0 is my unknown, but my time I know is 5, minus 1/2 g, that's just 1/2 times 9.8, becomes 4.9 times t squared, which is just 5 squared. All right, you solve all this out, solve for v0, and you end up getting that v0 is equal to 24.5 meters per second. Okay, not too hard. So now I have a value for v0, and now I can go over here, try to solve for my maximum height, s of t. All right, going back to my function, let me see if I have enough information now to solve for my s of t. I know my s0, I know my v0, I know 1/2 g, but I still don't know the time at which I have my maximum height. They don't tell us this in the problem, but you kind of have to infer it. So we have that our position function is represented by this equation here. If you notice, this equation is the same as a quadratic. It has a t squared term, a t term, and a constant. It's just a regular parabola that we're used to. And I don't know exactly what this parabola looks like, but I know it looks something like this. I know that at time 0, my position was at 0. My position is on the y-axis, and my time is on the x-axis. So at time 0, my position was 0. And over here, at time 5, my position was also 0. And my position went in this arc shape like this. And remember, a parabola, it's even on both sides. So the highest point happens exactly in the middle of the parabola. So if I took 5 seconds to go the entire distance, I know that my highest height was at time t equals 2.5, the exact middle of the parabola. So using that information that I just deduced, I'll say that at that when t equals 2.5, that's my maximum height. So I'm going to do the same thing, plug in all my values into this function, see what my s of t is. So now I have S of t, which is my unknown, is equal to S naught, which is 0, plus V naught t. Now I know those values. My V naught is 24.5, and my t is 2.5 times 2.5. Then minus 1/2 g, which is minus 4.9 t squared, or 2.5 squared. All right, once you plug all this stuff in, you should get that your S of t is equal to 30.625 meters. And that's your final answer. There's a couple different ways to approach this problem. I could have used this function to solve for my V naught, but I just decided to use this function for both of them. And there's a couple different ways you could think about this problem, but hopefully this was helpful.